Welcome to This Explainer. Today, we're going to decode the incredible mechanics of the Earth's atmosphere. We'll be uncovering exactly how this invisible machinery overhead shapes absolutely everything around us. From whether you need to grab an umbrella on your way out the door today, all the way to massive global shifts in our climate.
Here's our roadmap for today. First, Earth's protective blanket. Second, weather versus climate. Third, India's seasons and monsoons. And finally, climate change and us. Let's dive right in.
Starting off with Section 1, Earth's protective blanket. Now, we all know the atmosphere gives us oxygen to breathe, right? But it is so much more than that. It's our ultimate shield, held perfectly in place by gravity. Without this invisible layer, there would literally be no rain. Temperatures would swing violently from boiling hot during the day to freezing cold at night. Harmful UV rays would directly strike the surface. And those meteoroids we love to watch as shooting stars, well, they'd be crashing right into us. Simply put, without this blanket, life on Earth just wouldn't exist.
You know, you might assume oxygen makes up the vast bulk of our air, but nitrogen actually dominates at a massive 78%, which is absolutely essential for plant growth. Oxygen, the fuel for our breath, sits at 21%. But the real powerhouse here? It's that tiny 0.04% sliver of carbon dioxide. As small as it is, that tiny fraction manages the greenhouse effect and keeps our entire planet warm enough to inhabit. It's wild how much power is packed into such a small slice.
Think of the atmosphere kind of like a giant 5-layer cake. We live down at the bottom in the troposphere, where all the weather happens. Climb higher to the stratosphere, and you hit the ozone layer. This is ideal for airplanes because it's just so stable. Then comes the mesosphere, where meteors burn up, the thermosphere, which hosts those beautiful auroras, and finally the exosphere, fading out into deep space. But here's a really bizarre anomaly to notice. The temperature doesn't just keep dropping as you go up. In the stratosphere and thermosphere, it actually gets hotter.
Moving right along to Section 2, Weather versus Climate.
Okay, so time is the ultimate differentiator here. Weather is that hour-to-hour, day-to-day chaos of the atmosphere. It changes constantly. Sunny one moment, pouring rain the next. Climate, on the other hand, requires a minimum of 30 years of data. It's the long-term average. An easy way to think about it is this. Weather is your daily mood, but climate is your long-term personality.
But whether we're talking about a daily mood or a 30-year personality, they are both driven by 5 interconnected gears. We've got temperature, humidity, precipitation, atmospheric pressure, and wind, and they all trigger each other. When solar radiation turns the temperature gear, it changes the humidity, which shifts the pressure, which creates wind, which ultimately brings precipitation. It's a massive, continuous chain reaction.
Let's focus on pressure and wind for a second, because they follow one unbreakable law of physics. Air always moves from high-pressure areas to low-pressure areas. It's just nature's way of seeking equilibrium. This simple vacuum effect is the engine behind absolutely everything, from a gentle evening breeze to the most massive hurricane on Earth. And we can see this high-to-low pressure rule in action perfectly on the coast. During the day, land heats up way faster than the water. Warm air rises off the land, creating a low-pressure vacuum. So the high-pressure cool air from the sea rushes in to fill it, and boom, that's your cooling sea breeze. But at night, the whole script dynamically flips. The land cools down faster, creating high pressure, and the breeze flows back out to the warmer sea.
Let's zoom in a bit for Section 3, India's seasons and monsoons.
While the Indian subcontinent cycles through a dry winter, a scorching 40-degree summer, and a post-monsoon retreat, these are really just the opening acts. The absolute most dominant, landscape-altering force is undeniably the monsoon.
But what exactly is a monsoon? The word itself actually comes from the Arabic word mawsim, which just means season. But meteorologically speaking, the monsoon isn't just heavy rain. It's a complete seasonal reversal of the wind direction over the entire region. It is basically the ultimate land and sea breeze, stretched across a whole country and lasting for months at a time.
So here's that high-to-low pressure rule operating on a massive, continental scale. Step 1. India's intense summer heat bakes the landmass much faster than the surrounding Indian Ocean. This creates an intense, massive low-pressure zone right over the land. Meanwhile, high pressure sits over the cooler ocean. So the land acts like a giant vacuum cleaner, sucking those moisture-heavy winds straight off the sea and onto the subcontinent. And that is what brings the heavy rainfall of the southwest monsoon.
Now, this isn't just fascinating science. This matters to billions of lives. This weather engine is literally the pulse of India. The monsoon provides the vast majority of the country's annual rainfall. Its success or failure dictates agricultural output, food security, rural employment, and even hydroelectric power generation. A good monsoon brings vibrant life, while a poor one brings devastating drought. It's absolutely crucial.
Which brings us to our final section, climate change and us.
Let's shift from how the Earth works naturally to how we are actively rewiring this incredibly delicate system. Remember that tiny 0.04% of carbon dioxide we discussed earlier? Well, by burning fossil fuels, destroying forests, and creating pollution, human activities are pumping excess greenhouse gases into the air, completely altering that fragile balance, and the effects are profound. We're seeing global warming melt glaciers and raise sea levels. Long-term weather patterns are scrambling, leading to extreme, unpredictable events, like worse floods during the monsoon and harsher droughts when it fails.
To really understand our personal role in this massive global shift, we have to look at our carbon footprint. This is the total amount of greenhouse gases released into the atmosphere directly because of your individual daily activities. Every single time you drive a fossil fuel car, leave unnecessary lights on, or buy heavily manufactured goods, that footprint grows.
But hey, here is the empowering part. Shrinking your footprint is entirely achievable through practical, everyday choices. Choosing public transport or cycling instead of driving alone, conserving electricity and water in your home, planting trees which naturally pull that carbon dioxide right back out of the air, adopting a simple mindset to reduce, reuse, and recycle. These small shifts in how we live absolutely impact the mechanics of the atmosphere.
And that brings us to the end of our journey through the sky. We've seen how gravity holds our protective blanket in place and how pressure engines shape the lives of billions. The atmosphere has protected life on this planet for billions of years, but right now, who protects the atmosphere? Something to think about next time you step outside. Thanks for joining me for this explainer, and keep looking up.